This is A-level Year 1 Mechanics, and here we're looking at a lift problem, in particular a more complex lift problem where you're asked about the force exerted by an object on the floor of the lift. So here's a question. A woman of mass 60 kilograms is in a lift which accelerates upwards at 1.5 meters per second squared. Let's put an S in there. Find the force that the woman exerts on the floor of the lift. So when we start this question, it's really important you go back to your diagram and draw it out. And the one thing you're not given for this lift is that it has any mass. So in a good quality A-level question, they would always tell you the mass of the lift or tell you that the lift is light, meaning it's weightless, that you can ignore that it has any mass within the question. And I'm going to make that assumption within this question because we're not given that information. So T, tension, and that's on the cable that's pulling the lift upwards. And then I would also have here my person, which I've drawn as a block. If you want to draw it as a person, that's fine. And there would be a force acting downwards of 60G. And we're told that the lift is actually going upwards, so I mark on it the direction of my acceleration, and I know that's equal to 1.5 meters per second. Now, I know what some of you are thinking, but hang on a moment, this question hasn't got tension in it. This question is all about the force the woman exerts on the floor of the lift. I always need to start really with modelling my question this way, and you will see why when I move on to that, why I'm going to need to know tension. So just bear with me, let's go with this, and then we'll come and we'll work out how to answer this part of the question. So the first bit, I'm going to use F equals ma. And the force in the direction of the acceleration is T. Forces that are acting in the opposite direction, 60G. So therefore, my overall force is T subtract 60G. And that would be my mass, which is 60, multiplied by my acceleration, which is 1.5. So if I then type that all into a calculator, which you can do as well, we will get the answer of 678 newtons. So that's my tension. But I can already hear you saying, but what about the real part of the question? So the real part of the question says, find the force that the woman exerts on the floor of the lift. So I'm now going to draw out a slightly different diagram. And I'm going to need to move up the page to give myself the space to do this. So here's my new diagram. And this lady in this lift is exerting a force down this way. I need to give that force a letter. I can give it any letter that I like. There's no rule. So because I've got T acting in that direction, and that's 678, and in this direction down, I'm just going to call that the force that the lady exerts, and remember it does say on the floor of the lift, so it's there. And again, I'm going to use F equals ma. So using F equals ma, and what direction am I accelerating in? I must make sure that's clear, and it's like this. And this is all about scale pan now I'm looking at, or the lift. I called it a scale pan, but can I just say, sometimes they call it a scale pan and sometimes they call it a lift. If it's a scale pan, it'll have a mass on it. If it's a lift, it's got a person in it. And again, direction of motion my force here is going to be T, which I know, so I'm actually not going to use T. I might as well use my 780. Subtract S, because that's in the opposite direction, and that's the force you want to find out, remember, equals your mass. Now this is the bit that's tricky, the mass, because we're talking about the scale pan, or the lift, sorry. So we're talking about the lift here. What was the mass of the lift? Well, as we said earlier, it's not mentioned actually in the question, the mass of the lift. And I do think an A-level question on an exam paper would say either it's going to have zero mass or it's light. So both of those would mean that it's 0. Multiplied by your acceleration, which is 1.5. Which if you look, that means the right-hand side of this expression is 0. So 678, subtract S must be 0. So the force exerted by the woman on the floor of the lift I think I'm going to run out of space. The lift is going to be 678 newtons. Now, they may have written their answer to two significant figures, which would be 680 newtons. And it is possible in this question they could go for two significant figures. The reason for that would be, if you look at the two numbers that you're given 60 kilograms and 1.5. So therefore, they could be, both of those are two significant figures, and actually it could be argued that 60 is to one significant figure possibly. So there we go. That's your answer, 678 newtons. The key bit though is notice how I started it. I got involved in tension. Notice what I was actually trying to work out was this diagram here. That's what you needed to solve, but actually you couldn't solve it unless you knew what the tension was. So it still does come back to that basic problem. This is one of the trickiest A-level questions there are on lifts, and it's a real, I believe, one of those questions that makes the difference between you being one of the top students and one of the students that's good. This makes you excellent, so it's a really good one to get your head round.